Hello, you guys. Suppose it's time to do your math, so, I don't know. Maybe we'll do some now. Okay, 1994, number 4. Write the expression for the acceleration. So there is the velocity. And you just take the derivative. That's the first times the derivative of the second plus the second times the derivative of the first. And the derivative of t is just 1 minus 1. So it looks like it's a 1 and that's minus 1. It looks like the acceleration is just the natural log of t. B. For what value of t is the particle moving to the right? So we want to find out what value of t where this is positive. So we're going to set the velocity equal to 0. And then solve this. So t equals 0. And natural log of t minus 1 equals 0. And the natural log is 1 when t equals e. Okay? And this is a v. We've got two numbers, 0 and e. So if we choose a number to the left of 0, like -5, I think you probably get a positive. Let's see. 5 times the natural log of 5. For some reason, the natural log grows so slowly. Let's just check it out. What is it? T, x, natural log of x minus x. Is that right? And then let's plug 5 into that. Get a positive, yeah. And then in between 0 and e, like 1. Get a negative. And then after e, like 4. Positive. And we're trying to find out when the particle's moving to the right. It says time is always greater than 0, so I did not even need that part. But the particle's moving to the right. That's LE, isn't it? When time is greater than e. Okay, for C, we need to find what's the minimum velocity. So the way you find the minimum value of a function is you take the derivative of the function. So v prime, which is acceleration, right? And set it equal to 0. And then solve for for t. So we've got what, the natural log of t equals 0, and of course that happens at time equals 1. So we're looking for the minimum value of the velocity. And put 1 down. Now, I've seen more recently where they say that that's a 0, right? And I usually, if you put it on the number line, it is a 0, but I've seen new answer books have a little 0 above it, so maybe I'll start doing that. Like here and there. Okay, so to the left of 1, the natural log of something that's negative, or less than 1 is negative. To the right of 1 is positive. So we can find the minimum occurs at time equals 1. So v of 1 is 1 times the natural log of 1 minus 1, which is negative 1. The minimum velocity is negative 1. Okay. Now D. D asks for an expression for the position. Okay. And this is funny because I think what they wanted us to do is actually integrate this function to find the position function, use the initial condition to find the c value. But we don't know how to integrate this because you need to use integration by parts, which was a topic on the EB exam, but it is not any longer. But we can still find the position function, right? Because we can write the position function x of t as the integral of this. And then we can also employ that initial condition. So, you're not supposed to sneeze anymore. X of t is the initial spot, which is 6. Plus the integral of the velocity. Can you see that? No, you cannot. 6 plus the integral of the velocity from this time 1 to, oh, I gotta change these t's to x's. So I'm gonna make that a t here. And change these t's to x's. Because the variable that you use inside your integral can't be the same as the variable on the integral. Okay, so W, I guess, is as good as any. Hey! Yeah, 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 yeah.